This is really an exciting moment. Personally, this is my first keynote in my life ever, okay? Well, you know what? I prepared a script here, and then I realized that actually here, real time, okay, I don't need this script. So I'm going to be really honest with you and straightforward, okay? So let's see how it goes, okay? Okay, I'm Jun Park. When I got this invite for this talk, my first reaction was this one. You know, this is not inside my, script at all, okay? Really, real time, okay? So first, my reaction is, okay, why me? Why are you thinking about, I'm supposed to do this one? Well, I talked to, relevant people here, and then I realized that, oh yeah, it seems like you really try to listen to real user story on the first day of your first year summit. So I already kind of appreciate, oh yeah, seems like you're really ready to listen to user, then you already took your right first step to make it succeed. So I really appreciate. So let's see, I'm going to rely on my presentation file only, and then floating around that, okay? So, the question we would like to answer is how we can make dream come true, okay? Basically, I would like to share our true user story of SDN in live production. It's not POC, it's not small lab, it's not test bed. It's real live production where we fully utilize the SDN technology for our customer, okay? So, looks like this mountain is like a data center in Utah. However, it is just a small tip of iceberg. So today, we're going to look into inside the world, under the surface, okay? You may wonder who I am. I'm from Utah. This photo is very beautiful, the snow mountain. Right now, it's just like this, really. My home somewhere around in this photo. It's a very beautiful place. Behind this mountain, there is a name, called area named Sundance. I'm working with Bluehost, and my parent company is Indigenous International Group, in short, EIG, who went public last year. Basically, EIG managing tens of IT hosting company in US. So as a whole, one of the largest hosting company. We have not stepped in cloud market at all, but our underlying data center is all cloud. So we built our data center using OpenStack, one of, I think, the largest open source cloud platform. And we built our cloud system using SDN technology. Well, I made up this logo because I couldn't find the matching logo, so I just used a 3D cubicle box character stuff, so it seems like it's cool. Naturally, I became one of OpenStack developers out of 1,000 developers in OpenStack. And thankfully, I could have a chance to present some of our user story again over there. So this is one of recent talk that I gave at Hong Kong in China for the last OpenStack Summit. So let's listen up what he was talking about. That's one of our strong requirement. Have you seen this movie, Matrix? So Agent Smith, Hi, it's very interesting. He was talking about the movie Matrix in such a cloud conference, right? Well, if you're ever really interested in, looking to our technical deep dive, you can search in this YouTube video clip and slide file at the OpenStack website. Well, who cares who I am? You may care, actually, why I am here. I'm here today as a potential user of OpenDaylight. So congratulations, you already have potential user. It's so funny, right? Yeah, look at his face. He's so happy. This is our hope. We would like to use SDN technology just like him, really. Well, we just started. How far are we from that? I don't know. Until then, you know what? I'm going to be one of the pickiest users for OpenDaylight. So let's start. OK. Let's retrospect to the SDN itself. Here's the start button. Where did we start from? We started from this message, moving out controller from network hardware to separate controllers. It was a brilliant idea. We could immediately sense that, yeah, there's something there. This is very general SDN architecture. Most of them already familiar with this. So typically from the application, they send request to controller, and controller got that request through the northbound API and deal with that request using its own application control logic as well as network topology. Some of the controller is fully distributed already, or some are still single instance. And then actually controller deployed necessary OpenFlow entries against OpenFlow switch. Can be physical or can be virtual, anything that supports OpenFlow protocol. This is one of conventional SDN actually architecture, right? So the transfer of control was so fascinating because we believe that, wow, now we can really exit out from hell. You may guess what I mean by hell here. Notoriously, network management have been closed, proprietary, it's not scalable enough, inflexible, and eventually you're going to get the firm lock-in without having any reliable API. Okay, so we believe that, okay, finally we can exit out. So we at Bluehost, we really committed to utilize the SDN technology in our data center. And we surveyed and investigate all existing SDN solutions. And then we realized that, well, it's not going to be easy, seems like, because, wow, the flip side of the SDN approach gave us another hidden message. Now, your entire data center may be at the mercy of SDN controllers. Oh my God, this is so scary. We couldn't simply accept this approach. You may be sinking down into the deep water while praying with the SDN. Okay? So our SDN user story really started from this fear. What kind of concern we had more specifically? Yeah, we're concerned about this situation. What if we lost connection with the SDN controller? Entire data center can be down because of that? No, it's not acceptable. What if there's a bottleneck with the SDN controller? Everyone lined up, nothing happened. There's no OpenFlow entries deployed yet. No way. What kind of failable procedure there? Do you think this is the right failable procedure? I think it's happened to be the line of people waiting on the bridge. Well, these are all real serious concerns for live production. So, by understanding current limitation of the SDN approach, and we try to build up our own set of goals in terms of utilizing the SDN. The first goal was, since we chose to use the OpenStack, our specific goal was try to find SDN solution in the framework of OpenStack. And one of the critical requirements is that VM network should be recoverable when there are a lot of different type of failure, even when controller is completely down or it's not accessible, but still VM network should be set up. And of course, we need to find highly scalable solution. We couldn't even use a VLAN solution like that has a 4K limit already upfront. And the other very interesting requirement is very unique to our environment. As I said, we've been only focusing on hosting product, not yet cloud. Very interestingly, that gives us much more room, favorable room, so that we can focus on some specific goal and optimize it and get it. So initial goal was just focusing on public IP service using SDN technology. But even then, we have a bunch of actual requirements. They're supposed to be isolated network, even on one single VLAN, firewalls, anti-IP spoofing, QoS, all functionality needed to be implemented. You know what? When people understand the limitation and set up the proper goal, and typically they tended to be crazy. Okay? So we were crazy. We got some crazy idea here. I'm not sure the semantics of crazy here, crazily good idea or just crazy. Let's see. So we started to make some observation on our targeting platform, which is OpenStack. And OpenStack internally has its own separate to the network subcomponent, which is called Neutron. And Neutron agent is already fully distributed on every host. Meaning structurally, we feel that, oh, it's really good. Because that metaphor of that structure is, oh yeah, there's already isolated failure domain per host. And OpenStack actually, in fact, manages its own database for VM networks. Do we have to copy this same database to somewhere else? Well, so this was our idea. Why not embed SDN controller functionality itself to OpenStack? Yeah, this is a crazy idea. Let's look back the original SDN structure here. Well, typically is now in this context is OpenStack is one of kind of application for SDN. And one of possible solution using actually OpenDaylight here. Okay, OpenDaylight covers those parts. Controller as well as OpenFlow, all the way through down to actually OpenFlow switch, right? What we did is completely crazy thing. Somehow we embed some of, not all, some of the functionality of SDN controller into application itself. Yeah, of course it's crazy, but understand that. I'm not saying here the separating out controller from data plane was bad idea. What I'm saying here as a user, in order to access SDN, we have to have truly dependable and highly scalable SDN solution. Otherwise, we're not going to use any. So we built our data center using this approach, and let's look into inside. We've been managing more than 20,000 physical servers using only one instance of OpenStack. And 200 terabyte memory, 5 petabyte primary storage, 60 gig network bandwidth. And if you look at the network structure here, it's very conventional structure. There's L3 routers there and top of rack switches. The only difference here, every host now running OpenB switch that support OpenFlow protocol as a virtual switch, and that virtual switch managed by our custom Neutron agent. So here are the key services we successfully achieved using this framework. So completely isolated their network. Even though there are all VMs sit on one single physical VLAN. Sorry. And then firewalls. And we also implemented the anti-IP spoofings, all this stuff. Well, this is really deep enough. As I said, all detail stuff already shared in OpenStack Summit. And we also shared source code as well. So let's step back to see a big picture. So just like her, we were scared, but still watching it. Okay, seems like there's still something there. And as I said, we chosen to use OpenStack as a targeting application, and we embed the SDN technology into OpenStack. This is actually a big picture from user perspective. But what's really done in terms of SDN technology? Let me just borrow one very interesting diagram from our paper that was published in 2012. If you look at the author list, who is the first guy? Martin Casado, who is one of initial SDN inventors, who is now actually CTO at VMware. I had a five-minute chat with him regarding actually his paper. So I found we found that they have very similar recognition about this approach. Meaning he's like two different type of controller possibly deployed like this. One for ingress or egress edge switch, and then the other controller for the rest of fabric elements. So for us, what we've done, actually, according to this diagram, we're basically embedding the edge switch controller functionality into application itself. It was possible, actually, we've been focusing on some limited functionality only, for example, like a public IP service only. For the next phase, we realized that actually, okay, for the fabric controller, how are we going to deal with that? Yeah. So, I'm here, as a user, right? We somehow successfully deployed and tried to utilize SDN, but still we found that some limitation in even our approach. That's why I'm here to get your help. We need to somehow get it done in a proper way. So that the fabric controller part, still we haven't done anything. Okay? Regardless of whether the people use a separate external SDN controller or just embedded structure, the real stuff is that actually we effectively moving edge switch from the top of rack switch to host that's running Open switch. Because of that, we could achieve this stuff. Each host now can manage only its own open flow entries. It's completely isolated, failure domain. And we could successfully implement all rich services using Open switch. And upon various failures, of course, yeah, still agent can work with its own cookies, even when SN is down. Well, what's going to be next to what? To our environment? Well, as I said, we really want to expand our experience of SDN to tenant private network as well. One of possible option or direction would be utilize overlay network, for example, VXLAN. There are a bunch of overlay networks that somehow is really, we can see that the overlay network is really good synergetic with the SDN direction. The other possible option is utilize the open flow compatible switch. By the way, in our data center right now, actually, we're using IBM switch, and then IBM switch already support the open flow protocol. That's why, okay, we are kind of ready. I mean, we have not really turned on, but once we decide any direction, we can immediately utilize actually those stuff. Now, I'm going to be questioning. First of all, the embedding. That idea is really conflict with the conventional SDN approach. It's going to really mess up entire structure, or still it is possible to somehow, organize well into some of the targeting or something. It's just questioning. I'm not here to say our approach is right on or is really good on. At least it's been successful to us, but still is questioning. Along with that first question, how we can actually relate different application to SDN framework. For example, OpenStack. During the OpenStack Summit, I'm I'm delivering kind of this kind of message to them. Like, think about that. We needed to have SDN solution. Right now, at this point, that's the only way you can successfully virtualize network in OpenStack. I'm emphasizing to them. And I'm here emphasizing, please talk to OpenStack, help them. They really need your help. All these questions from this question, actually, okay? As long as there is a really good, failable procedure, we are going to be fine. Until then, yeah, we're going to ask a lot of questions like this. So this is final slide and final question. Where is SDN headed? Well, as you know, we've seen a lot of different requests of application. Like not only north-west traffic, there are a lot of requests for east-to-west traffic among VMs. And recently, actually, as you can see in Google before, they utilized the SDN technology for their traffic engineering. It's kind of different application of SDN. And another interesting trend, as you can see here, like typically for the network chipset, custom silicon is a high profile, it's really high performance. Now is kind of trend to merchant silicon, still is good enough. Even further, they try to utilize generic CPU like x86 and GPU for replacement of network chipset. At this point, I don't know who's going to be the winner, but we are seeing that this kind of trend. So for example, like when you run OpenVSwitch on host, actually that the virtual switch is running on x86, not using any merchant chipset, but still probably there are some limitation there. So recently, the Trident 2 chipset support VXLAN protocol. Well, I couldn't find that chipset image, so I just borrowed one of my fabric gum Trident here, sorry. Anyway, so some of merchant chipset really start to support VXLAN protocol. And as you know here, in OpenDaylight Summit, there are a lot of sub-projects already going on. OpenFlow, OBSDB, DPDK, VTN, OpenDove, Lisp, Defense 4, and so on. So a lot of stuff is really going on. This is all good sign. Well, let me read this title again. Question, where is SDN headed? Well, we are here on the first day of OpenDaylight Summit to make the dream come true. Thank you.